ahum suba lecture oidoni kosina. So let us start redox reaction. This is the third lecture. 3 marks. So redox chemistry ki matang what is reduction reaction, what is oxidation reaction. Now today we are going to talk about some of the important rules which we have discussed in the previous classes. So before going to the rules, I'm going to quickly summarize again what we have done in the previous classes. Reduction reaction oxidation reaction okay. See, when you say oxidation reaction, oxidation means losing of electrons, clear? And reduction means it is gaining of electrons. Okay, gaining of electrons. So don't forget these two concepts. Okay, now we're going to find the oxidation number rules. Some of the rules are: number one, oxidation number of free elements, they are always going to be assigned 0. Oxidation number of free elements will be assigned 0. For example, let us see some of the important reaction which takes place in HERBERT's process. Nitrogen and hydrogen, if you react, you're going to get ammonia. Okay, nitrogen and hydrogen, if you react, you're going to get ammonia. So now let us assign the oxidation state. So rule number 1 says that the oxidation state of free elements, which means in the uncombined state, the oxidation state will be assigned 0. 0 is there. Now, how to find the oxidation state of nitrogen? Let us see. Let us take it as X, and the oxidation state of hydrogen will be always +1. So it equals to 0. Now X will be equals to -3. So -3 is the oxidation state of nitrogen, and hydrogen is taken as +1. So don't forget this, okay? In the uncombined state, the species which does not combine, they are going to have the oxidation state equals to 0. So who will tell me what species undergoes oxidation? Kanano oxidation chatari se, adagi kanano reduction chatari hai bisa. I know what will be the species which undergoes oxidation and what is the species which undergoes reduction. I have told you in the previous class, the one which increase in the oxidation state will be oxidation. Oxidation number 100 reduction. As you can see, nitrogen is changing its oxidation state from 0 to -3. Hydrogen is also changing from 0 to +1. So what may be the species which undergoes oxidation and what may be the species which undergoes reduction? You can unmute yourself and tell me.
Nitrogen undergoes oxidation, nitrogen undergoes reduction.
Okay, why nitrogen undergoes reduction? Nitrogen in a reduction chathari se kagino -0 to -3 had to say decrease nidana. Decrease in the oxidation number will be, is it reduction or oxidation? It will be reduction. Okay, and the species which undergoes increase, kanano increase to visha 0 to +1 is increase, so this must be oxidation. So this is a better way of defining which is undergoing oxidation and what is undergoing reduction. Species in a oxidation state increase tauragadi oxidation. Species in a oxidation state decrease tauragana reduction. So higher point the first rule is oxidation number of free elements. Okay, they are going to be assigned the oxidation state equals to 0. Then point number 2 says that oxidation number of fluorine. Fluorine is an electronegative element. Okay, group 17 element, the first family, that is fluorine. So now let us check what will be the oxidation state of fluorine. So according to the rule, it says that the oxidation state of fluorine will be always -1. Don't forget, oxidation state of fluorine is -1, and 4 species which are free elements that are assigned 0 oxidation state. Then point number 3, oxidation number of hydrogen will always be equals to +1 unless it is combined with a metal. Okay, metal is in the electrochemical series. We have many metals which are arranged based on their reactivity and oxidation potential. So can anyone tell me what will be the can anyone tell me the electrochemical series starting from lithium, potassium, adora if you can recall?
Potassium, calcium, sodium, magnesium, aluminum, zinc,
Yes.
iron,
Yes.
lithium, hydrogen, iron, lead, hydrogen, copper,
Yeah.
silver, gold.
Okay. If we have some problem remembering these elements, I'm going to give you a thumb rule. Okay, this rule is going to be very helpful for you. Just remember the sentence. Okay, remember the sentence. The starting letter will correspond to the name of the metal. So it's very simple. Just remember this sentence. What does the sentence says? Kings cannot make a zebra. Kings cannot make a zebra. I like his car, silvery gate. Take out the first letter from the word of the sentence. So K corresponds to potassium, C corresponds to calcium, N corresponds to your sodium, okay, M for magnesium, and so on. So if you can take out all these letters one by one, you will have the elements arranged in the series, starting from the high reactivity to low reactivity. So just remember, kings cannot make a zebra. I like his car, silvery gate. So we know that the oxidation potential of hydrogen is 0 volt. Then for zinc, it is say minus 0.76 volt. For copper, you have to remember some of these important values, 34 volt. So when you go from potassium up to lead, the oxidation state or the oxidation potential is negative of 0.7. Habidi elements in minus potential level. Down the group the potential for the element keeps on rising, which means hydrogen ki makhada level elements in less reactive or never. Okay, knowing this, we're going to come to the third rule of oxidation number. Just before coming to the rule, remember this series first. Potassium, calcium, sodium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, silver, and gold. So after remembering this, we should come to the next rule. That is rule number. Masai rule number ring, rule number 3 the last thing. So don't forget that rule. This point number 3. Point number 3 says that hydrogen will always be assigned oxidation number +1. Okay, unless it combines with reactive metals. Unless it combines with a metal, oxidation number of hydrogen will always be -1 if it combines with metal. However, those metal must be above the hydrogens. Okay, Masai kings cannot make a zebra. I like his car, silvery gate having ninjamo. Hydrogen ki mathakta laiba singdo combine toramagadi hydrogen ki oxidation state number set -1. Say for example, lithium hydroxide. Lithium lies well above hydrogen in the electrochemical series, which means lithium is far more reactive than hydrogen. So if you want to find the oxidation state of this lithium, you're going to say this as X plus the unknown is always taken as X and it is equals to 0. X will always be equals to 1. So what will be the oxidation state of lithium in lithium hydride? +1 to -1. Okay, same thing for sodium hydride, magnesium hydride. So you are given some important points. Given the points are: number 1, oxidation number of free elements will always be equals to 0. Point number 2, the oxidation number of fluorine is -1. Hydrogen is always +1 except for metal hydrides. Point number 4. Okay, next point number 5. Point number 4. There's some missing points here. Should be point number 4. This must be point number 4. Okay. So in their compounds, say all of you can start finding out the oxidation state of carbon in carbon tetrafluoride. If you know the answer, you can tell me. Let us all calculate here and let us assign the oxidation state. Find out for carbon in carbon tetrafluoride. If you got the answer, tell me. How to find out? You are given the rule that the unknown X plus fluorine is always taken as क्या आएगी -1 नत्रा यदि x की वैल्यू क्या तार है माइनस और प्लस +4
+4
+4 लादी को
+4
fluorine की -1 अदगी नोइना काउरोइदबा मा सिगी कार्बन गा हाइड्रोजन मरी पुले सिदा क्या तादोइन अमता हाइरो what will be the oxidation state of carbon for methane? If you got the answer, you can tell me.
-4
Yes, X plus 4 plus 1, because oxidation state of hydrogen will always be +1 if it combines with other than non-metals. So X will be given as -4. So what is X? This is the oxidation state of kanagi carbon +1. And in the same manner, if you keep on finding oxygen kya -2, what about carbon? What will be the oxidation state of carbon?
+4
+4
Plus minus for hydrocarbon. What about for carbon tetrachloride? Substitute the oxidation state. -1.
+4
+4. Okay, in the same manner, you can find out for carbon disulfide ammonia. So rules for assigning oxidation state. This is an example, okay, for various types of non-metals. Now we'll move on to the next rule, rule number 6. Okay, reduction oxidation reaction based on oxidation number method. So I think I have already mentioned about this in the previous class also. Before coming to the next rule, let us do this some example problems. So oxidation reaction is a chemical reaction which is accompanied by oxidation number. Increase in the oxidation number is oxidation. Decrease in the oxidation number corresponds to reduction. So I have told you in the previous classes also, if you want to find the species which undergoes oxidation, just check whether it is increasing in its oxidation number. Now let us see. I have given the first rule, that is the oxidation number in the uncombined state will always be kya hoiba? Aluminium da kya hoini sidhairo? What will be the oxidation? 0.
0
Sida kya lai? +3. This is increasing or decreasing? 0 degi +3 is increase.
Increase.
So will this undergo
Increasing.
oxidation or reduction?
oxidation
Very good. Very good, very good. Oxidation. Now, can you assign oxidation or reduction for the second problem? Sulfur gise?
reduction
Very good. Because it is decreasing. Imran will decrease with the sulfur gi the uncombined state in a 0 lani -2 the gi. Okay. No, this is oxidation or reduction?
oxidation
Yes, it is
Oxidation.
It is oxidation because it is increasing in the oxidation number. So this is also an example of oxidation. So reduction or the oxidation number decrease. So tin with oxidation number 4. What is the atomic number of tin? Can anyone tell me? I have already completed periodic classification of element. Tin belongs in which family? Boron, carbon, nitrogen, oxygen, fluorine, lead. Tin belongs in which family? Anyone? See, group number 13, boron, carbon, nitrogen, oxygen, fluorine, neon. So, aluminium, gallium, indium, thallium, carbon, silicon, germanium. So, tin litra. Okay. redox chemistry ki concept se lak ai noi da point number hiram ge. You try to remember all the names of the elements belonging in the P block. Let us do a quick revision for P block. So like carbon, boron de hong si ko, boron, carbon, nitrogen, oxygen, fluorine, neon layer. Simta ke helium, neon layer ke argon, krypton, xenon, radon, fluorine layer ke chlorine, bromine, iodine, astatine, sulfur, selenium, tellurium, polonium, phosphorus, arsenic, antimony, bismuth, silicon, germanium, से तीन ले रहे तो अखोई ना पाम इधर तीन बर्गर lead, boron, learn by heart all this, gallium, indium, thallium. Then put the magic number. What are the magic numbers? 2, 8, 8, 18, 18, 30. Okay, so
32.
atomic number of helium क्या लाइस द 2. Magic number क्या नो आप तो इसे 2, 8, 8, 18, 18, 32 निको. So 2 plus 8 क्या था 10. हैरबा मथंग द 10 plus 8 क्या था 18. 18 plus मथंग द लाख इसे 18 plus 18 क्या था 36. 36 plus another 18 क्या था 50 का
4.
Okay, 54 का 32 एतर क्या था 86 था ब्रा
6.
86.
Now the magic number हापल हो
86.
Yes, लोइन पुथोप यार तो रे को स्माइल पुथोबा नो युम द इबसा नगदा बसे 17 16 15 क्या लानी सिदा 14 13 अदुदी लोइन पुथोप यार तो रे को 3 के एटॉमिक नंबर से क्या होने यार अदुदी 54 ले रे 53 ले रे
50.
2 ले रे very good 51 ले रे सिदा 50 okay सिगी कार्बन से करी ग्रुप नो ग्रुप नंबर 14 ने को ग्रुप नंबर 14 होता है गदी कार्बन फैमिली ने बा 3 से so group number 14 द लेतो इसे ngo the configuration ay mamang periodic classification su ta bani how to find the group number ns2 plus np electrons 1 to 6 layer magadi 3 sanaro ko it ranges from 1 to 6 plus 10 so in our particular case 2 plus kya layer 4 plus sigi 10 chapten doine ba aduna takpadi the general configuration is ns2 np np kya hoidi ba np2 so electron se ani mang matam da yes tin dagi electron ani mang matam my oxidation state ani lakani ba adagi ns2 dagi pulap mari mang gitari tin gi oxidation state cha mari laktoi ne ba oxidation state ha bisi bu kaino mang gi matam da lehoga da charge element na puga da charge na oxidation number ha de ba charge number do aduna sigi tin sa magi oxidation state che khongi se kamai la ino do ina khara manung huna ta ko si loina ma kha draga swer adubu concept si maru hoeba no atomic number dagi magi electronic configuration adi kamai na oxidation state khongai no hai bising sa in details phajana khanga da bani ko atsuka tawra chapadi ade aduna ni ina makok ta gi takala is mamang da su ta khrabani khangda ya da po ching ni khanga da ko so tin with the oxidation state 4 layer adu de hainer ro this tin with valency 4 plus it is increasing or decreasing to 2 plus losing electron nico
Decreasing.
okay will this undergo oxidation or reduction
Reduction.
very good
Reduction.
okay now tell me what will be the oxidation state of this chlorine
0.
0 because rule number 1 okay high elemental state to the assign 0 to high see the minus or the increase or decrease 0 degi 100 is handai ko aduna kai time madi it is undergoing reduction sigi point and high myam sini kawarnu ji pawda rules khara high grabani ko mamang di sta ga labni ngasi amuka hena khamna ba haina ai mokte taglai ni kom ka matang is point the last utility generally ke high sida metallic elements of group B has oxidation number more than one type according to Mendeleev's classification elements a subgroup ani thona khaidoi A and B okay so these elements which belongs in the B group they have oxidation number more than one type oxidation number ꯑꯃꯗꯒꯤ ꯍꯦꯟꯅ ꯂꯩꯌꯦꯕ ꯃꯣꯏꯁꯦ ꯃꯈꯟ ꯃꯈꯟ ꯂꯩꯗꯣꯏꯅꯤ ꯑꯅꯤ ꯑꯍꯨꯝ ꯂꯩꯈꯠꯂꯛꯀꯗꯣꯏꯅꯤꯀꯣ oxidation state ꯁꯦ so these elements belong in the group B namely for example zinc silver copper okay apart from zinc cadmium and mercury moibudi transition elements ta chandre so hojik hairishina copper gumba gold gumba iron gumba lead gumba moisingdadi oxidation state se ani ani legaleba ko iron go iron gi magi oxidation state +2 ferrous iron 2 plus then ferric iron Fe3 plus stock notation da koina igiba kanda kamai gi ferric oxide se Fe3 oxide man inagi ko adagi ferrous oxide FeO se kamai gi Fe2 oxide sumaina mamangi class in hagi bido stock notation season arga ibusu yai hagi ko adagi point number 6 tana hai se kaino hai kanda sodium barium sida ferric iron chloride iron sulfide iron myam pire haningedi oxidation number of single atomic ions yantarba polyatomic ions haigana sulfate ion gumba haibadi atoms myamna punjalaga sabugumba ko natraga nitrate ion haibugumba moi gumba sidadi akoina polyatomic ion haigdaba point number 6 na hairisi ke haigel kanda for this monoatomic ions the oxidation number is equal to the charge on that ion oxidation number is monoatomic ions di moi na puriba charge to ka mane haiba sodium ion de kya lani di +1 barium de kya lani +2 ferric ion de kya lani FeCl3 da +3 adidi hairo what will be the oxidation state of iron kya tani sa +3 tai dana ko ferric ion de so koi kya lamani di +3 level so masa masala pugadaba charge to aduna moi ki oxidation state ni haidu sulfide ion da bu hairo sodium sulfide da sulfide ion lai ko sulfide ion has -2 oxidation number kawbe adresi ki rules kara se aduga koi matang da problems what see with respect to that and then rule number 7 the high ishingo the sum of the oxidation number of atoms of all elements in a compound is equal to 0 unless it has charge charge pudaba species tadi moi na pugadaba total number of elements the sum of oxidation number of all elements in a compound is equal to 0 0 ga manani hai moi gi total sum se I believe for example sulfuric acid natraga water handlers example na kudam na water loroge water ki formula dino lo khange H2O ni ko H2O sida legadaba charge in sing se sida hydrogen kya yawi hydrogen ani yawi hydrogen amana pugadaba charge cha +1 ni rule number 3 na hai gre ko +1 ni except if it combines with metals so plus sida kya lani oxidation state of keno sa oxygen ki depan -2 ni hai gre so ani se combine to bukanda +2 ka -2 they always 0 ta draw left hand side equals to right hand side to me ko so this is verified meaning body sum of the oxidation number of all the elements in a compound is always equals to 0 ka mana ga diba then next rule number 8 says that noi muna taw ko si lor kai noi da hai han doi ni ko what are the topics which we have taught today hana rule number 1 dagi e paw higher ka da banoi na the sum of the oxidation number of elements in a polyatomic ion is equals to the charge carried by the ion. Kuda moina sida sulfate ion hai siko sulfate ion sida akoina khange sulfate ki magi charge si kyano -2 ni ko sulfur na pugada ba charge apoi hana puthoki siko sida yengasi x plus 4 -2 equals to sida kya lai charge sa -2 ni sida mana hala si -2 adu soft obviously ko 4 to the 8 -2 so the oxidation state of sulfur will be kya tani +6 sulfur have to say group number kya do belong to we sulfur belongs in group number kya do belong to we oxygen family ni ko group 16 da very good oxygen sulfur oxygen belongs in second period sulfur belongs in third period adu tari ma se third period ki elements ni ado configuration igi hai targa di kya lani 3s2 3p4 ani se tin janaraga plus 10 to 16 tai dana ko aduga nearest noble configuration igi neon and smile yam line thun iba iba haina bo hona ro ko so oxidation number puthok hai targa di yengo sida akoi electron se mang ba ya doi ne ba aduna sulfur na exhibit to bi abel my oxidation state se makan makan ani +4 ma mang gadi ama 4 mang kitari plus 4 ani sida laiba ani se muka pulak mangchan kitari plus 6 4 plus 2 pulak mang gibi ai dana ko valence cell digi electron lo thokpe am laiba. So either plus 4 plus 6, these are the common oxidation state of sulfur. So sigi elements mayam se punja laga charge sila manani hai. Point number 8 hai se kaino the sum of oxidation number of elements, okay, in a polyatomic habidi atom mayam punja laga saba ion the ko mogi charge sa ion duna puri ba charge to mana do ni hai ni. So oxidation number of each and every atom punjan biro charge to equate to minero x ki value puthok pa yadore ko. So hoji phawda koi rules nipan tame. So before coming to the exercise part adura nang kara summarize to ro mamang da akoina hoji phawda maina give points rules nipan se nan akang bodo chitha horaga se kuchu kai chitha dana honor
yan hanbada isolated natraga free state the oxidation number se always 0 oigani. Ani shubada monoatomic atom singidi oxidation number se makoi ion singdugi charge ka manani.
very good.
Oxygen se super oxide amadi peroxide ki state da laiba matamdo oxygen final laini.
Yes,
Oxygen na fluorides amadi difluoride semba matamdo oxidation number se +2 and +1 haina laini. The number of oxygen will be positive. Adubu madudi bonding state depend tawi.
good.
Hydrogen gi oxidation number se +1 haina laini except for metal ga bonding taw matamdana -1 haina laini.
Wait, natangai ko
Algebraic
adura aduda electrochemical series ta pigi baina mnemonics ama ngasai ningjang na ba haibudo ningjang hairo kai haigi
kings cannot make a zebra. I like his car's silvery gate.
now tell me the electrochemical series.
Potassium, calcium, sodium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, silver, gold.
Very good. Now come to the next rule. After hydrogen oxidation state protocol rekanda.
Molecule amada, the sum of the oxidation number of the elements is 0 ga manani. Aduga polyatomic ion singdana oxidation number gi algebraic sum se ion adugi charge ga manani.
Very good. Now exercise amo hochi ko. Sida ina kudamoina sulfuric acid ne potassium dichromate gi dichromate ion lotoe. Sida question hotoi ne ba. Mamang da soina home assignment na sukra budi pigre. Project amuka tawsi ko hena khangna ba. Sulfuric acid sida noina puthokada basa. Sulfur ki oxidation state se puthokse. Sulfur ki oxidation state puthoke hai taraga dis minor pekada pirak pe ai ko. Noina like khara dus thengarami. Find the oxidation state of the underlying species haina. Adu taraga di rules me am decision naraga koi sulfur ki oxidation state puthokse. Yeng si ko kamay puthokada ge sa. Ai na tai si da oina yengo atei sina noi help oina yengo su ai ko. Hydrogen ki magi oxidation state always +1 logani high grade except if you combine with a metal. Dagi sulfur gina x lobirani oxygen gina kya lobu tare oxygen gina -2 ni ko. Adagi si 0 ka mana han tare solve to matam da sulfur ki oxidation x hai +6 tara ani. So you are going to assign here +6. Adagi potassium dichromate lower see it is a yellow color orange powdery solid ni ko. Sige potassium dichromate sige koina chromate ion auto kitaragadi sige -2 charge in matakta lakrani aduga Cr2O7 sa -2 ni. Nasai rule number 7 ga 8 season araga akoi chromium sige oxidation state puthok ko kamaina puthokadage do harake x hybirasi puthokada species na adagi 7 into -2 because oxygen gidi oxidifluoride ka dioxyfluoride natana oxidation state of this oxygen will always be taken as -2 peroxide. So then we apply rule number 8, 7 and 8, -2. I think it's solved the zero. After solving, you'll definitely find the oxidation state of chromium in dichromate ion will always be +6. This +6 will be assigned here. So this is the way how to find out the oxidation state. Now all of you try to work out a problem. Find the oxidation state. Okay, this is the class test, just like classwork. Find the oxidation state of Roman number 1, the underlying species manganese ki puthoro in potassium dichromate, potassium permanganate. Then anisubada sulfur ki puthoro oleum. This is called oleum. So if you can find out, you can tell me the answer. Now calculate the oxidation state of the underlying species manganese in potassium permanganate, sulfur in oleum. Those who can solve the answer, if you got the answer, tell me what is the value you got. Plus or plus hapiro, minus or minus hapiro pa. Plus minus yadre. This is a classwork. All of you try to solve. Your home assignment will be uploaded tomorrow. Okay. Try to remember all these important rules which we have discussed today. Now, those who got the answer, you can tell me what is the oxidation state of manganese.
+7.
Plus 7.
Plus 7 tayo.
Okay.
+7, sir.
Let us check. Potassium gidi apoina kya lower ni magi balance +1. Then manganese kina x lobirasi 4 minus 2. Oxygen gidi always -2 low high. Apply rule number 7. You get 0 ka mana hello. Very good. You get +7. So mathak sida +7 hand thambiro. Now try to calculate for sulfur in oleum. Sulfur gidi kya laige hai to sulfur gina kya no?
6.
+6.
+6. Noi loina answer ta normal le ko. Ta da yaw bagi da ma soft to bige soft da ba kamu gi da magni ko. Yengaro ai traga de da soft to bige. This is going to be +6. So let us see how +6 is derived. So +1 multiply with 2 plus twice into x +7 minus 2 0 like hello. So the x soft to be very good. +6 and +7. Mathak ta hapiro oxidation state species to gi mathak ta hapnai ko. Okay, remember the rules. It is not a very difficult topic. Oxidation number puthok pasi yam maru oi kaw busi ade heng wai no practical titration tawkini ko redox ki application makala mani ko titration of okay acid and base. Mathang da last dudi so the high ratio examples. This is an example to show you the change in oxidation state. iPad yung jalo kay haging usida. Example number 1. Masay potassium permanganate lagiba ion sa. Akoy na potassium silog to kanda lagidaba ion duni ko. This KMnO4 sidagi ionized to mo tamda kay pigani potassium ga MnO4 minus. Sige MnO4 minus siga akoy iron siga iron salt ama loro ko in acidic medium. Aduga magi change in the oxidation number si yeng se. So sigi manganese ta +7 lysin no lo yaning mani khange x plus 4 minus 2 equals to -1 ni ko. X ki value kya tare +1. Aduna +1 lai re. Then iron gi di man uba charge to koi low high grade rule number 8. Then sigi hydrogen gi na kya hoy lakani +1. So after calculating, let us see which is the species undergoing oxidation. Ingo sige manganese sina product on matam da change in oxidation state cha increase or decrease
Decrease.
then
Decrease.
which is the species undergoing oxidation and which is the species undergoing reduction habudo hainaro.
And iron undergoes oxidation.
Yes, very good. Decrease. This decrease in the oxidation number corresponds to oxidation. And iron is undergoing reduction. Iron ko. This is the better way of defining oxidation reduction. Am thuna puthoko yara adoi ne bojikte. Ako oxidation number rule tabin. Aduna mathangi class ta amu continue to siko. Let us come to the application type. Okay, for today, side loisalasi. So ngasi takiba points se amuka quickly brush up toro ko. Kaubi adre rule ni pandu ningjongo. Yarba. Okay. In the next class, I'm going to come to the application part. Okay, application part of this redox chemistry. So ngasi kay important points ta kage habido moi remind to moro nasana set afidi rules kara hairo how to find the oxidation number.